So the Java virtual machine is an abstract machine that runs Java applications. And we can see in the diagram that it consists of three parts: specification, implementation, and instances. So it's a single specification with multiple implementations. So we kind of need a single specification, otherwise it would kind of all go haywire. So the most common implementation right now of the JVM is the OpenJDK. It was originally developed by Sun Microsystems, and then Oracle purchased Sun. In terms of instances, an instance is what runs a Java application. So you have the JVM, and then you have the implementation of that, and then you have an instance, which is what actually runs a Java application. And applications on the JVM are compiled to what's known as bytecode. So for us, in terms of running applications, and developing applications, there's two parts. There's the Java Runtime Environment, or the JRE, which is basically the environment that is needed to run a Java application. So anytime you download a jar or a class file and you want to run that, you would need to use the JRE. You need to have the Java Runtime Environment installed. If you want to develop applications, which is what we're going to be doing today, we also need the JDK, which is the Java Development Kit. And so that is mostly for development. Now, Java, one of the great things around Java is that it is a very polyglot environment. So if you're familiar with .NET, you have the .NET framework, right? And you have the CLR. And the CLR is basically known for two main languages, kind of Visual Basic and C#. And there is F# as well from Microsoft. But it really is kind of a platform on which Microsoft is, waving the flag of what languages are going to be developed and what languages are available on the CLR. In the Java ecosystem, it's really different. There is Java, which is now Oracle, but there is no single vendor that's providing different languages. And so it's really a truly polyglot ecosystem. And all the languages on this JVM either compile to bytecode or they transpile first to Java. Now, examples of languages include Kotlin, obviously what we're covering in this course. There's Scala, there's Ceylon, there's Clojure, which is Lisp for the JVM. There's Frege, which is Haskell for the JVM. And all of them, as I mentioned, compile down to bytecode. In terms of Kotlin and the JVM, how does this actually work? So here we have some code in Kotlin, which is a customer.kt file. And we'll get into the syntax and all of that a little bit later on. But right now I have a class, which is a customer class. And what I do is I basically compile this with the Kotlin compiler. And this generates for us some bytecode, which has the extension customer.class. So that is the JVM bytecode. And then this is then executed in one of the instances of the JVM. So this generates an output, and then we can execute this using Java and then the name of the application, which in this case could be, for instance, my app. So important to grasp here is that all languages have source code, which can be Java, can be Kotlin, can be Ceylon, can be whatever. They get compiled into bytecode, and then the JVM is what executes that bytecode. Now, in terms of Kotlin and Java, as I mentioned, one of the goals was for them to be 100% interoperable, and they are. And we'll see this in the segment around interoperability. Now, the good thing about this is that you can actually call Java from Kotlin and vice versa. So I can have a Java class that I can call a Kotlin class, and a Kotlin class that can call a Java class. And so you can mix and match Java and Kotlin in your projects as you feel and you see fit. You can also use, obviously, Java libraries and frameworks. So you don't need to reinvent the whole thing. You don't need to kind of like say, okay, now I'm using Kotlin, and now I need a Kotlin web framework. I need a Kotlin zip library. I need this and that. You can actually use all of the existing JVM libraries and frameworks that exist. And as I mentioned, when we get into the section about interoperability, we'll see more of this. But it's important to know that we have designed this to keep in mind that there is going to be a mix and match of Java as needed, obviously.